Hello everybody, Mr. Slope Guy here today to help you with systems of equations with word problems that involve money problems. And if we look at some examples, let's write down example number 1. We have John has $1.70, all in dimes and nickels. He has a total of 22 coins. How many of each kind does he have? So, all these equations with systems involve two different variables. So we're going to want to define the two different variables from the problem. The two different things we're talking about in this case are dimes and nickels. So we're going to define the variable by letting d be the number of dimes, and we're going to let n be the number of nickels. Now, if we're using two variables, we always have to write two equations, and those equations can come in various forms. Two very common forms they come in, it's what's called a counting equation and a value equation. So a counting equation kind of has to do with the number of things we have. Like in this case, we have 22 coins. We have a number of coins. We can count those really easy. They add up to 22. So that can be one of our constraints, which is one of our equations. So first equation we're going to do, if he has 22 coins and they're all dimes and nickels, is we can do the counting equation of d plus n is 22. Then our second equation is a little bit more difficult. It has to take into account that dimes and nickels are worth different values. We know that dimes are worth 10 cents. We know nickels are worth 5 cents. So we have to take that into account as part of what's called the value equation. So our value equation, we're going to differentiate dimes and nickels. And I would prefer to use decimals for the money because to me, if you're using 10, you want to use the whole number 10 for dimes. For $10 bills, and 0.1 or 0.10 for dimes. Same thing with nickels and 50-cent pieces and $5 bills. I would try to use 5 for $5 bills, 0.5 for a 50-cent piece, and 0.05 for nickels. So when it comes time to write the value equation in this case, I want to use 0.10 for D, 10 cents for each dime, so D will multiply by 10 cents. 0.05 for nickels, so that each nickel is worth 5 cents, and we know we have a total of $1.70. Then we can go through and solve by any of our methods of solving systems of equations. We could solve by graphing. We could solve by substitution, elimination. In this case, I chose to do elimination, and when I look at that second one with the 0.10 for the D, 0.05 for N, 1.7, I would multiply everything by 100, which will move all the decimals over 2 places and give us 10D plus 5N plus $1.70. I could stay with the decimal places. I would just have to be very careful not to lose any of them. But multiply by 100 will change that to all whole numbers. Then if I'm looking to do elimination, I would take this top equation, and I could either multiply by negative 10 to get the D's to drop out, or take the top equation and multiply by negative 5 to get the n's to drop out. So I chose to multiply by negative 10, and then if I just look at these bottom two equations, if I look at adding those together, I do have my opposites I need for elimination. My d's could cancel out, and positive 5n plus a negative 10n gives me negative 5n, and positive 170 plus a negative 220 will give me negative 50. Then I could divide both sides by negative 5, and I get that I had 10 nickels. And then back in the original problem, we knew that the number of coins added up to 22. So if I have 10 nickels, I must have 12 dimes. And I can go back and I can take that n equals 10 and substitute it in any of the original equations and get that dimes would have to be 12. And I can always double check, make sure it works in both equations. All right, let's look at a new example. You have $150 all in 10s and $5 bills. There are 23 bills. How many 10s and how many 5s do you have? So we want to define our two variables. The two things we're talking about in this case are $5 bills and $10 bills. So I let T be the number of 10s, and I let F equal the number of 5s. Then I'm looking for my two equations to go with my two variables. And since I'm told there are 23 bills, I know that the number of 10s plus the number of 5s have to add up to 23. That's the quick and easy equation. 10s plus 5s equals 23. And in that, I don't have to take into account the different values. The second one, equation I'm going to write has to do with it adding up to $155. that's where I have to take into account that $10 bills and $5 bills do not have the same value. So I want each 10 multiplied by 10, or t times 10, and every value of f multiplied by 5 to make the $10 bills worth $10, to make the $5 bills worth $5, and we have a total that it should add up to 155. Then I'm going to go through, in this case, I'm going to solve with elimination. If I wanted the t's to drop out, I could multiply by -10. If I want the f's to drop out, I could take that top equation and multiply by -5. I pick 1. In this case, I just pick to get the f's to drop out, take that whole top equation, multiply each one by -5. The most common mistake people will make on that is they'll forget to multiply this -5 to the 23. So you want to make sure you multiply it to the entire equation, not just parts of it. That would give me -5t minus 5f equals -115. Then if I do elimination, the f's will eliminate. They'll drop out. 10t plus a -5t is 5t. And 155 plus a -115 will give me 40. Then I have 5t equals 40. Divide both sides by 5. And I get that there must be 8 $10 bills. And then I can use that t equals 8. I can go to any of those original equations. Like, let's say I use the 10t plus 5f equals 155. Put 8 in for t. Subtract 80 from each side. Divide by 5, and I get f is 15. Or I could have done the equation where I know the number of 10s plus the number of 5s added up to 23, so the f must be 15. Either of those equations will work. Then we get 8 $10 bills and 15 $5 bills. All right, last example. Let's look at Alex. Good old Alex has 103 gold and silver coins in his safe worth $83,150. If the gold coins are worth $2,000 each and the silver coins are worth $50 each, how many of each kind does he have? And this one works well for both the types of equations we're talking about. That won't always work. Sometimes there could be two values. Sometimes there could be two counting equations. But in this case, we're going to do the same counting and value equations we did on the other two. So first, we're looking for like the number of coins. Number of coins gold, number of coins silver. We'll define our two variables. Let G be the number of gold coins. Let S equal the number of silver coins. Then our counting equation, where the number of G plus the number of S have to add up to 103 coins. G plus S equals 103. And then our value equation, we're going to take into account that the gold coins are worth $2,000 each, and the silver coins are worth $50 each. So 2,000 times G plus 50 times S would equal our total amount of money worth $83,150. Once you have these two equations, then you can use any of our methods of solving. Elimination works so great, so easy. I like to do that. So I want to look at getting the G's to drop out or the S's to drop out. Since I have a positive 50S, I can multiply that top equation by -50 and make the S's to drop out. I just need to make sure I multiply the entire left side, the entire right side. So I get -50G minus 50S equals -5,150. Then I'm looking at adding these two together. 2,000G plus a -50G, 1950G. My S's eliminate, they're opposites, they're inverses, they eliminate. And 83,150 plus a -5,150 gives us 78,000. Divide both sides by 1950, and I have 40 gold coins. Well, I know my number of coins added up to 103, so if 40 of them are gold, how many of them have to be silver? Well, I take 103 minus the 40 from each side, get 63 silver coins, so I must have 40 gold coins and 63 silver coins for Alex. He's rich. All right. Hope that helps you guys with some money problems with systems of equations. Have a great day.